Hi, my name is Asnawi and I'm going to present part A. So for the sub-experiment 1, to measure the resistivity of copper wire and estimate the related error. So for this experiment, we have taken the what we call the data, and this is the data looks like. For the calculation of the data, we can see in the table in the video. I've calculated it using the Excel, which I will show you. This is the Excel that I use for calculation. As you can see, I have the average length. I have all the data that has been calculated using the, as you can see here, all the calculations are being done in the what we call that in the data. And then we have the standard deviation, standard error, and this is what the result is like for the length. And then we can see next is for sub experiment 2. This is how the data looks like, and as before, the calculation in the table are being done using the Excel as well. As we can see here, this is the experiment for the resistance, and as usual, I use the formula here, and we calculate as well the standard deviation, standard error, and the result for resistance are as follow. And the last one is sub experiment 3. This is the data for the experiment, and this is the table with the data. And for the Excel, this is the Excel with all the calculation that has been done in here. And also we have calculated as well the standard deviation, the standard error, and the results of the part A experiment are as follows.
We have going to the part B, where it's mostly about the calculation things. So first, here is the range obtained after we calculate by using the simple formula given. So from the data and the range, we could obtain histogram graph and also the Gauss curve graph. Here is the area under the curve, which after we calculated, we obtained 0.72 meters square. So what is the value of the standard deviation is, firstly we have to calculate the determining range for area under the graph. So theoretically, the range of mu minus standard deviation, which is sigma, and mu plus sigma is 68% of the curve. So it makes the area under the curve between mu and mu plus sigma is equal to 24.5, as I wrote here. And from there, we could obtain standard deviation for this sample. So what is the maximum value for the curve? That we could say is 0.211, which is n over n. So standard deviation sigma. So this is how we obtain from the formula up here. Just have to modify the formula here and just substitute few informations and data that we have, and hence we could obtain again standard deviation. Okay, so here we have to compare the result from both method 3A and 3B. So it's more about the standard deviation obtained by A is higher than standard deviation obtained by B actually. So this because of discrepancy of between these two is the curve in the graph is not accurate actually. There are some region which is not completely bounded under the curve. And it is also difficult to be counted, so we can say that it is just an approximation for method A. So hence method B is more likely to use as a standard deviation for a diameter of wire. Conclusion, the copper wire at the temperature of 27 degree is 1.86 plus minus 0.02 exponent negative 8, and it is insignificant.